What I'd like to do in this lesson is show how to create classes in Scala that use generic types. So what I'm going to do is just create this class. I'll call it box. You might call it container, but I'm going to call it a box. And declare that it's going to have one generic type, and I'll call that A. As I mentioned in other videos, when you use generics in Scala, the first type parameter typically begins with A, the second one would be B, and so on. So in this one, I'm going to use A, and then I'm going to call the input parameter A also, and give that generic type right there. So this part here would just be like if I had an integer parameter I called I, and then the type was int. But instead of that, we're going to say the parameter name is A, lowercase a, and then the type is this generic A right there. And just to make it a little bit more interesting, I'll add in a get method here and say something like, well, get string equals, and I'm going to say A equals $A. And if you had more methods like this, you would just keep adding them in this section right here. And the same thing if you had other members like fields, they would all go in this area right here. So now to get started, I can replace that and I'll say, well, val b equals a new box. And because it's generic, I can put anything I want in there. So I could put a string like that. So let's call that one S, let's say for string. And then we can create another one and we'll call this one I, and I'll put an integer in there. So we'll put 42 in there. And now we can print those. So I'll print line S and then print line I like that. And save that. And I have the compiler running over here. And let me move things around just a bit more like that. And what I'm doing wrong here is instead of calling S, I want to call s.get. And then I want to call I.get right there. And there we go. So that has the results right there that I was looking for. And now to make this a little bit more interesting, what I want to do is add in some other code here. So I want to create a trait named fruit. And I'll say def color is a string. So if you recall from previous lessons, this is how you define an abstract member in Scala. You define it with the def keyword, and then you put its value over here. So that's a string. And as I mentioned in those lessons, when you extend this, so we can create an apple, let's say extends fruit. Now, when you extend this, you can extend it as a def field if you want to. You could also extend it as a var. But I'm going to extend it as a val, so then I'll say val color for a fruit equals red. And similarly, we could do something like this and say, well, I want to have, instead of an apple, how about we'll also have a banana, and its color is going to be yellow, like that. So now that I have those types there, I will keep this code. Let's comment that out for now. And now what I want to do is create an instance of an apple. So we'll say apple equals that. And we'll say banana equals that. And then just to keep things relatively simple, we'll say, how about I want to have a box of apple. And what I'm going to do is declare this one as an apple. So you'll see what I mean in just a second. And what I want to do here is say, I want to create a box of apple. And I'm using this type apple right here. And I'm going to show you something a little bit different in just a moment. But right now, let's just do that. And then we could say print line box of apple, and then get on that one and save that. And you can see at this point, I have this output here, and that's because this does not have a toString method. So if I go back to the trait, actually, this is a good example. I could say, well, toString equals the color, and then save that, and I'll need an override, right? Override. And there we go. So now because I defined toString in the trait here, it will be usable inside of apple and banana, as you can see right there. And what I meant when I said box of apple as apple right here is you could also say something like, well, I want to create box of apple as a fruit. So you could specify here that I don't necessarily want that to just contain apples. I want to let it contain any kind of fruit. And then I'll do that and save that. Let me scoot things over and then do a get on that. And there we go. So far, so good. You don't really see any difference yet, but if I hover over this, you will see that this is a box of apple right there, as far as the compiler thinks, and this one is a box of fruit. So now that we've gone through a few examples, let me get rid of that right there. And now what I want to do is create a function, and we'll call this one print color. And this one is going to take a box of fruit. That's the input parameter name. And then I'm going to say, well, that one is a box of fruit. That's its type right there that I want to accept. And then unit equals that. And then print line, box of fruit. Then I want to get its A parameter right there, which is this one right here. I want to get that A parameter and then call color on it. And that doesn't compile because I did not call that one a val. So let's do that. And there we go. So many moons ago, I talked about this parameter right here. So A is the name of the input parameter. And if you don't give it a val or var keyword right here, then that won't be accessible, as you just saw in that example. But if I make it a val, that gives this A value an accessor method, so I can access it like this right there. And as I mentioned, again, a long time ago, if you make that a var, you'll get both an accessor and a mutator method, but I don't want to do anything like that, so we'll just make that a val and save that again. Now what I want to do is give myself a little more room to work with here. And indeed, we can get rid of that print line statement. Let's get rid of that one too. And now I'm going to call print color. And the first thing I'll pass it in is the box of apple as apple. And save that. And actually, I did the wrong one first. I wanted to do box of apple as fruit like that. There we go. So you see that one work with that red output right there. So what's going on here is that print color expects a box of fruit right there. And when I first tried to pass in a box of apple as fruit, I had defined that as a box of apple, and that wouldn't work. So that's why you saw that error message right there. And indeed, if I copy that and put it here, change that back to apple, and save that, now we'll see that error message again. So we know that this one works right now, and this one does not work right now. And the reason it doesn't work is when we come back up to the box class up here, I define the type as A. And as I've mentioned in other videos, when you define the type as A, that means that A can be used as both a producer and consumer in this class, or that box is a producer and consumer of types A. But really, if you look here, all I'm doing is getting the A value out. It does come in here, but this one doesn't count for that purpose. You know, you have to populate your box with something. So that doesn't count there. But this one here, I am using a get as a producer method. So I'm producing that. And as I mentioned in another video on bounds, is what you do to make your code more flexible when you're only using your class as a producer of types A, you can put a plus A right there. And now if I save that, you'll see that this works right here. So we get two reds. We get one from here and one from here. So this is more accurate if I say works with A. And then this one I could change to say this one works with plus A. And I'm just going to save that again real quick. So this is the kind of thing you get into. So the purpose of this particular lesson is to show how to use generic types with classes like this. But I also wanted to get into bounds like this just a little bit to show you what that means. So again, this one right here is a producer of A. And as long as this class only produces A, we can mark our code with plus A right there instead of this. And when we do use that plus A like that, we're telling the compiler, I'm only a producer of types A, and therefore the compiler can look at a function like print color and say, oh, okay, even though I expect a box of fruit right here, what I'm willing to do is also to take in subtypes of fruit. And that's only because I am saying that box is only a producer, and therefore this is safe for the compiler. And so then if I want to be a little more clear down here, I could say, well, this one is right there, and then this one is right here. Bear with me just a moment, and we can get rid of that and save that. And I'm thinking maybe that's a little bit more clear now because you can see that more directly. So print color expects a box of fruit as an input parameter. So therefore, you probably thought that this one would work right away, and indeed it does work. And then the second one here did not work, and that's because I had created this one as a box of apple instead of a box of fruit like I did that first time. And when you only have the A in there, that won't work. But when you have the plus A, then the compiler again is like, oh, okay, you're only going to be a producer of type A. You're not going to take in other A values. So this is safe for me to allow. So again, I just wanted to show how to use generic types with classes, and that's what I'm doing here. And then as a little bit of a bonus, I suppose, I threw in the plus A right there and showed just a little bit more of the flexibility that that gives you. And again, to me, it's a best practice that if you know that your class is only going to be a producer of a certain type, then go ahead and mark that with the plus A as I have done right there. And to me, that makes your intention clear about what you're planning or what you're thinking.